Hi, this is Michelle. In this section, we will think about more topics on functions and their graphs. Now let's think about relative maximum and minimum. Let's consider those four graphs. Whenever you are given any function graph, the minimum and maximum of a function means the highest point of the function graph and also lowest point of the function graph. Then if you look at the first one, because we are keep going up and down, so there is no maximum, there's no minimum value. The second one, because it is keep going up, there is no maximum. But because we do have the lowest point here, let's say this is -3, then there is minimum value, which is -3. And if you look at the third one, it is keep going up and keep going down like the first one, so there's no maximum, there's no minimum. And the last graph, because it is keep going up, so there's no maximum. But if you look at the minimum here, let's say this is -1 and this is -3. Then the lowest point we can have from this graph is here, right? So the minimum is -3. But now let's think about relative maximum and minimum. Sometimes if you look inside of the function graph and if you think about locally, then sometimes you get a minimum or maximum, right? For example, the third graph, we didn't have any minimum or maximum. But if you think about around here, then we know we have minimum value here, right? So in this case, we call it as relative minimum. So even though we didn't have any minimum, there is relative minimum. Same idea. If you look at up here, we didn't have any maximum, but here we can have maximum locally. So say this is 2. Then we can call this one as relative maximum. So even though we didn't have any maximum, we do have relative maximum 2 and relative minimum -2 in this case. Also, if you look at the fourth graph, now at that time we had one minimum value, which is -3. But if you think about locally here, and this point is also a minimum value, right? So in this case, we have relative minimum value as -1. Also, our original minimum value is also a relative minimum. So in this case, you will have two relative minimum values. We call it as two relative minima, -1 and -3. And also, if you look up here, let's say this is 1. Then now, we didn't have maximum, but we do have relative maximum. The value is 1. And if you look at the second one, we had minimum value. If you look locally here, still this could be relative minimum value. So we do have relative minimum value, which is -3, which means all the minimum and maximum values, these are also relative minimum and maximum values. Maximum, there is no relative maximum. So in this case, there is no relative maximum. Also, if you look at the first graph, even locally, we don't have any minimum or maximum. So in this case, there is no relative maximum and there is no relative minimum. So in general, whenever you have any graph, any portion of the graph is pointing upward or downward, these are relative minimum and maximum values. Example 2. So now we want to find out all relative maxima and minima. If you look at this part, this is relative minimum. And if you look at this is relative maximum. Then we can see the maximum value is y value, which is 2 at x equals 1. Or sometimes you can just write it as an ordered pair. In this case, your y value is your relative maximum value. Same idea, relative minimum value. Minimum value is your y value, which is -2 at x equals -1. So, or you can write it as -1, -2. So again, your minimum value is -2. Next example. Previously, we had the guidelines and the numbers, so we can read the graph. But in this case, we don't have the guideline. Instead, we have -391 by -4025. So first, you have to understand what those numbers are. If you look at this graph, this window is pretty familiar, right? As you can see, this is exactly same as your graphing calculator. And the bottom numbers are talking about window of your graphing calculator. So first three numbers are talking about your x, second three numbers are talking about your y. First set of three numbers are x minimum, x maximum, x scale. Second set of three numbers are y minimum, y maximum, y scale. So because our x minimum is -3, here is -3, and here is 9. And then between the tick marks, we have 1. So -3, -2, -1, 0, 1, 2, 3, and etc., etc., 9. And because y minimum is -40, so this is -40. And then maximum is 20, so up here is 20. And now because our scale is 5, now we are not counting by 1, we are counting by 5. So this is 20, 15, 10, 5, 0, -5, and like this. Okay? So the problem is this. Even though we can find the relative minimum and maximum here, so relative minimum is here, relative maximum is here, because x squared is 1, so we can read the x value as 1 and 4. We cannot be sure about the y value because the scale is 5, and also we are not sure if the point is exactly on the tick mark. So that's why they gave us the function expression. So in this case, if you are not sure about your y value, to find out your relative maximum or minimum values, you have to evaluate your function using your x value. So number 1, relative maximum. To find the relative maximum value, we have to evaluate the function with x value 4. So -2 x cubed plus 15x squared minus 24x minus 19, and plug in 4. So equals -264 plus 15 times 16 minus 96 minus 19 equals -128 plus 240 minus 96 minus 19, which is -3. So the relative maximum value is -3 at x equals 4. Or we can just write it as 4, -3. And since the relative minimum is here, to find out the relative minimum value, we have to evaluate the function with 1. So -2x cubed plus 15x squared minus 24x minus 19, and plug in 1 here. So -2 plus 15 minus 24 minus 19, which is -30. So the relative minimum value is -30 at x equals 1. Or we can write it as 1, -30. So most of the cases when you are given graph like this and also the function expression, usually we evaluate the function with each x value to find the relative maximum or minimum.